Okay, so in this video, I'm going to show you guys the usage of a rule which is known as the Cramer's rule, and which is very handy when it comes to solving systems of equations using the matrix method. Okay, so suppose I'm just going to do a simple case first, and the case is, suppose you have these two equations. Okay, so a11 into x1 plus a12 into x2 equals to b1. So just imagine this is an equation. So just a11 are just coefficients, right? So it could be 5x1 plus 6x2 equals to some number. And then you have another equation here. Now, if you have an equation like this, I don't know if you remember, but it's possible to write these equations out in a matrix form by putting by clubbing the variables together. So if you remember, what we can do is you can write out this equation in the form of matrix like this. So you can write a11, a12, a21, a22. So what I did was I just took all the coefficients here, and then you can write another matrix like this, x1 into x2. So if you have these two equations, you can actually write it as the multiplication. So this side, the left-hand side of the equations can actually be written like this. So essentially, if you remember that, remember the matrix multiplication. So if you do a matrix multiplication, you're going to see that this is going to create a matrix. So this is going to give you these two equations if you do a multiplication of them, and then you can write this is equal to another matrix b1 into b2, which is the results. So you can just take all these numbers and you can arrange them and put it in the matrix form. Now the Cramer's rule is it's a very interesting way in which you can actually find out solutions from x1 solutions for x1 and x2 from these three matrices, and I'll just show you what the formula is. Okay, so the Cramer rule says if you want to find out what is the solution of x1, find out what is the, okay, so this is your matrix A, this is your matrix X, and let's say this is your matrix B, so into X to B. Okay, so let's just call it that. So the solution for x1 will be equal to 1 divided by the determinant of A. Okay, so 1 divided by the determinant of A into the determinant of a special matrix. So this special matrix is, you take the matrix A, but what you're going to do is you're going to replace this first column by the solutions or the elements in your matrix B. So 1 divided by the determinant of A into this special matrix where you're replacing this column here, okay, this column here with B1 and B2. So it's B1 by B2 into these. So then the other two elements will be the same. Okay, so the Cramer rule says if you solve this expression here, you can actually find out the value of x1. Okay, and x2 will be, again, it will be 1 divided by the determinant of A into the determinant. Now what you're going to do is, over here now for x2, you're going to take this column a11, a21, but then this second column is the one you're going to be replacing with b1 and b2. Okay, so these, if you compute these these two expressions, you're actually going to solve for x1 and x2. So this is known as the Cramer's rule. And the Cramer's rule, if you notice, if you remember that in chapter 15 we were trying to solve for, when we have a system of equations, you try to solve for them. We learned a couple of methods, right? The Gaussian elimination, and then doing elementary row operations. So the Cramer's rule is a third way in which you can use if you have a system of equation. You can rearrange them into these kind of matrices, and from here the Cramer rule says the solution of x1 will be this and the solution of x2 will be this. So this is another interesting way to find out to solve for systems of equation. Okay. So you know what, let me do an example. Okay, let me show an example, and I'm going to do the example 16.1.2. so I'm going to do example 16.1.2. okay, so what is 16.1.2? So in 16.1.2 you have an equation, system of equation with two equations. Okay, so this is from page 624. So the two equations are 2x1 plus 4x2 equals to 7, 2x1 minus 2x2 equals to minus 2. Okay, so this is what we have. And so they say, okay, solve for x1 and x2 from these system of equations, but now we want to use this Cramer's rule. So remember that we can write this as a matrix form. So you can take all the coefficients 2, 4, 2 minus 2 into x1, x2. This will equal to 7 by minus 2. So you have a matrix A, a matrix X, which equals to, let's say, matrix B. Okay, now how do I find x1 and x2? We're going to use the Cramer's rule. Okay, so remember x1 is 1 divided by the determinant of A. So 1 divided by the determinant of 2, 4, 2 minus 2 into, what did we do? So we said what we're going to do is we're going to write this special matrix and find the determinant of it. So I'm going to take this matrix A here. The first column is going to stay the same, but then the second column, so because I'm finding x1, my first column is going to get replaced by these numbers here. So it's going to be 7 minus 2, and then these numbers actually stay the same. Okay. So if you compute this, you will actually be able to find out the solution of x1. So let's see if we can do this. Okay. So what is the determinant of this? So the determinant of this is 2 into minus 2. So it's 1 divided by 2 into minus 2 is minus 4, minus 4 into 2, 8. Okay, so you have this here into 7 into minus 2 is minus 14, minus 4 into 2 is 4 into 2 is 8. You have a minus here, so it's minus 8. Okay, now you can simplify this, right? So minus 4 by minus 8 is minus 12, and minus 14 minus makes it a plus. So this is going to be plus 8. Plus 8 minus 14 is what? This is minus 6, right? So if you do this simplification, so minus 6 divided by minus 12 is half. So actually x1 will have a solution which is equal to half. So this is a solution we have found using the Cramer's rule. Okay, now what is going to be x2? Let's also go ahead and try to solve for x2. Okay, let me just write x2 here first, because then we can make use of these numbers here. So x2 will be the same. It's going to be 1 divided by the determinant of A. So again, it's the same, right? So it's 2, 4, 2 minus 2 into, now you have to write this special matrix. Now, since this is x2, what you're doing is you're keeping the first column the same. So it's 2 by 2 and 2. But now you're replacing the second column with 7 by 2. 7 by minus 2. Okay. Now, if you do this math here, this is going to give you the solution of x2. Now, notice that I already calculated the determinant of A, right? So I don't need to do it twice. So what was the determinant of A? It was minus 12. So I can write 1 by minus 12 And then what is this determinant? This is just 2 into minus 2. So this is minus 4 minus 7 into 2 is what? 7 into 2 is minus 14. Okay. So if you do this, this is going to be, let me just squeeze this in here. Minus 14 by minus 4 is minus 18 by minus 12. So if you simplify this, you're going to be left with 3 by 2. Okay. So this is your solution for x2. So this is basically an example which I've taken from which I just read from the textbook, but which shows how you can use, if you have a system with two equations, how you can use the Cramer's rule to solve for x1 and x2. Okay, so try out a few more problems. This is relatively, it's just a technique which is very useful to solve simultaneous equations.